So if you notice what happens to the ball, is it starts to lift up, and you can go faster. And this is even easier to do if you're not on a table like that. So if you notice that the ball lifts up, and it goes from this position here, and it picks itself up to here. You notice it isn't up here, and it isn't down here. It's because the angular momentum of the entire disk, when it's rotating, wants to be kept along this sort of equatorial. So whenever you look at the planets and you're like, well, why are they rotating along this way? Sorry, I'm out of wind. Being rotated takes a lot out of you. It's because they're trying to conserve the angular momentum of the entire solar system. So this is really cool. We can take something really, really simple like two little cars you throw against each other, add in a length component, say that conservation has to stay. And then you can start to get things like, what shape should the whole universe take on? What, these large things, the entire planet, how does it move? But we know that's not just all. We also know that there's an orbital component and an angular component. So you have these planets, they're not just drifting around like a ball in a circle, they're also rotating. And every new solar system rotates a certain way, but I'm gonna just start like this. So, let's see. I don't remember if I do this, you notice that I'm rotating this way, and my wheel is rotating like this. If I try to turn it upside down, I rotate the other direction. So there is a definite relationship between the rotation of my planet, this wheel, and the direction it moves around the solar system. In the case of the solar system, we believe that they started to get a regular movement, and then they started to pick up more of an angular velocity associated with it. But if you look at solar systems, especially young ones, oftentimes all the planets are rotating around the sun, orbiting around the sun in the same direction, and they're orbiting along the same direction. And weird anomalies like Uranus, and I can't remember what other one rotates in the opposite direction. They know some outside force that disturbs this conservation of angular momentum has active. So just from this, we can learn a lot about our universe. We know that there had to be large collisions in our own solar system. We know that all solar systems should behave more or less like our solar system. So we know that we're not too special, which, I mean, from like a dreamer's point of view, you're like, oh, maybe if we get interstellar flight, we'll know how those orbits work. But also, it's something really beautiful about where we live. And I think that's all of this demo that Jack and I talked about. We talked about it like before the freeze.